Hello everybody and welcome back to the Educalysis channel, the channel where we analyze and educate you all on a whole bunch of different topics I find reasonable. Today, we will be talking about the multiverse theory and a whole bunch of different parts, branches, and things that relate to it. So for this video, we are going to be splitting the multiverse into 5 different sections. I will say when a section starts and when a section ends and when we start a new area of what we're talking about. Each area has about 3 main ideas, and on the last one, which is section 5, there are 6. So we're going to be breaking down each one and talking about it more in depth. Now, here's the definition of multiverse. Multiverse, a hypothetical group of multiple universes. Together, these universes comprise everything that exists: space, time, matter, energy, info, laws, constants, etc. The different universes within the multiverse are called parallel universes, other universes, or alternate universes. So, Section 1. In Dublin, 1952, Erwin Schrödinger gave a lecture saying that he was about to sound basically like he was on 19 pounds of meth. What he was trying to explain is that whenever he had an equation that came up with something that could explain many different histories, he didn't think of it as they were all just alternate histories, but that all histories were going on at once simultaneously. This is the first instance of the idea of the multiverse theory coming true. The main theory relates to the fact that every single different idea basically can be split off as a different reality, and that's what this theory is all about. So when he said that all these different histories were happening simultaneously but not alternate, he basically meant anything that could be explained in that history for that equation had actually happened, and it did exist. Now, the first time the term multiverse was used was actually in 1895, but it was in a different context. This term was used for the reason we know it now by Michael Moorcock in 1963 when he wrote a novel. Multiple universes is a theory and a hypothesis in a whole bunch of cosmology, physics, astronomy, music, and literature pieces. The debate between who believes this and who don't has been alive for decades, maybe even centuries. Some physicists claim that this isn't a legitimate topic of inquiry. And along with that, concerns have come around about the damage of trying to prove and test this hypothesis. It could, theoretically, damage studies of physics and our world around us as we know it. Something that is often brought up is the fact that the theory cannot be falsified. Under the idea of this theory, everything has a non-provable explanation. This was brought up highly by Paul Steinhardt, arguing that no experiment can rule out a theory if it provides all possible outcomes. In 2007, Steve Weinberg suggested that a multiverse does actually in fact exist. That concludes Section 1, and now we are on to Section 2. Around 2010, scientists such as Stephen Fernie analyzed WMAP data and claimed to find evidence that our universe collided with another parallel. Although, when people went back and analyzed data from the WMAP and from the Planck satellite, which has a 3 times revolution of the WMAP, they did not reveal any statistically significant evidence of such a bubble universe collision. In addition, there was no evidence of any gravitational pull of other universes on ours. Now, a big thing with the multiverse theory is classification schemes, which are different ways of projecting the multiverse. Right now, we are going to be talking about max tier marks for levels, that there are universes beyond our observable universe. Level 1. Basically, there are universes 10 to the 10 to the 115th meters away from us, and considering infinite universe size, there will be an infinite amount of Hubble volumes identical to ours in the universe. Level 2. In the internal inflation theory, the multiverse of space as a whole to stretching and continuing this process forever. Some regions, however, have stopped and formed distinct bubbles, like air pockets and rising bread. The third level doesn't contain more possible Hubble volume than 1 or 2. Like 2, bubble universes with different physical constants can, in effect, be found as worlds created by splits at the moment of spontaneous symmetry, breaking in a level 3 multiverse. Level 4. Basically, he implies that any conceivable parallel universe theory can be described at level 4, and subsumes all other assembles, therefore bringing closure to the hierarchy of multiverse, and that there cannot be, say, a level 5. Jürgen Schmidhuber says that the mathematical structure is not well defined, and he admits only universe representation describable by constructional mathematics is computer programs. Basically what this all means is that each different level is its own different universe, and multiple universes, and 1 and 2 get increasingly bigger, but 3 stays as big as 2 and 1's sections, and that level 4 is all other theories, basically. Another way of structuralizing it is Brian Greaves' 9 types, which are 9 types of multiverses. That is the end of section 2, and now we're going to start section 3. So here I'm going to give you 3 examples of Brian Greene's 9 types, and then I'm going to explain the other 6. So the first type is quilted. This only works if there are an infinite amount of universes, which would allow all these other things to work. Next is brane. He says our universe exists on a membrane, which floats in a higher dimension or bulk. The third one is quantum. The quantum multiverse creates a new universe whenever a diversion in events occurs, as in the many worlds interpretation of quantum mechanics. The other 6 are known as inflammatory, cyclic, landscape, holographic, simulated, and ultimate. First is inflammatory. It is composed of pockets which collapse on themselves, forming new universes. Cyclic has multiple branes, like in the last one, causing big bangs which go through time to collide with one another. Landscape is based off of string theory, dropping shapes to a lower EGL, creating different laws of math and physics. Holograph is derived of the theory that the surface area is encoded with the contents of the volume, basically meaning everything on the surface of the universe is encoded with everything that could possibly be in the universe. My favorite is simulated, and the theory is that we exist on a complex computer system that simulates entire universes. That example isn't as far off as VR, basically meaning we are all in a different reality of a computer simulation that someone else is running us through. And last is ultimate. It contains every mathematically possible universe under different laws of physics and like gravity and all that. Next, we will be talking about M theory. A multiverse of somewhat different kind has been theorized within string theory and its higher dimensional extensions. These theories require the presence of 11 or 10 space-time dimensions respectively. The extra 6 or 7 dimensions may either be compacted on a very small scale. Our universe may simply be localized in a dynamical 3+1 dimensional object, which would be considered a DB brane. This opens up the possibility that there are other branes that can hold different universes. This opens up the possibility that there are other branes which can support other universes. That concludes section 3, and now we're on to section 4. Black hole cosmology is the cosmological model in which the observable in the interior of a black hole existing as one of the many possible universes inside a larger universe. A good example of this is us being like a chocolate chip in a cookie. This includes the theory of white holes, which are the opposite side of space and time. Now, there are 3 main holes when it comes to science and theoreticalness, and I know that sounds really weird, but just bear with me. The first is black holes, which we could use as a possible entrance to new universes. Second is white holes, which we could possibly use as a machine to create new matter out of nothing. Last is wormholes, which would be the only way we could travel far distances in space in a reasonable amount of time. If there were a large or possibly infinite number of universes, each with a different or possibly different physical law or different fundamental physical constants, then some of these universes, even if very few, would have the combination of law and fundamental parameters that are suitable for the development of matter, astronomically big structures, elemental diversity, stars, and planets that could exist long enough for life to emerge and evolve. Now, we're going to be talking about Occam's razor. Occam's razor basically meaning the problem-solving principle that states that Entities should not be multiplied without necessity. The idea is attributed to William of Ockham. That concludes section 4, and we are on the last section, section 5, finally. So the main thing we're going to talk about right now is model realism. Modern realism states, possible worlds are a way of explaining probability in hypothetical statements. Some philosophers, such as David Lewis, believe that all possible worlds exist, and they are just as real as the world we live in. Now, there are different ideas of thinking of the multiverse, and I'll be talking about different ways you can think of them. The first way we're going to be thinking of it is imagine a circle, a nice big circle. Then it splits into two slightly smaller circles. Each of those slightly smaller circles breaks into two more slightly smaller circles. Repeat process for every single microsecond, millisecond, second, any time frame you can think of. And that's what the decisionary part of the multiverse is. Each section or each circle is a different multiverse, as a different event can occur. This would go on infinitely, proving that there would be infinite amounts of universes. The main one that is most understandable to believe, and that doesn't really involve the multiverse, is if you think of a circle, and then to the right there's another circle, and then to the right there's another circle, never branching off. That is basically our universe, and the best way to explain how one universe would work. Everything just going forward in time, never branching off, and everything just stays in one motion. So the best way to think of this last one is like a tree. So take a tree, but it has an infinite amount of branches, each branching off of each other forever. This would be a way of thinking of the multiverse. So the stump of the tree would be the idea that there is multiverse, that something happened, and that something is happening. Each branch, branching off of each other, would be different decisions and different things that could happen and that are happening simultaneously and alternately. Now, since we're getting close to the end of this video, I'll give you some simple synonyms of parallel universe. Alternate universes, quantum universes, parallel realities, alternate timelines, interpreting dimensions, parallel universes, quantum realities, alternate dimensions, parallel worlds, alternate realities, and dimensional planes. Now, some other small ideas that are in the multiverse theory, which I'm going to say but not really give too much in-depth analysis on, are the theories of déjà vu, the Mandela effect, void patches, and the star HD 140283 and its age. Now, the last thing I'm going to leave you with is the thought that the multiverse theory actually kind of contradicts itself. If you think about it, and if every different idea in every different universe has a separate universe where something didn't happen, there was a different conclusion or a different idea, that means that there are universes where every single other universe, including ours, was completely destroyed, completely forgotten, completely replaced, all these kinds of things, which would mean that we wouldn't exist. And since we are here, we know we do exist, considering if you move your hand to the right, you know you did something. That means that in that case, it sort of contradicts itself, but yet again, that can be proven because the theory cannot be falsified. So that's the end of my whole multiverse theory episode. I thank you all for watching. I hope you all enjoyed. If you did, please just share it with everyone else. Like I said in the intro, this video and these videos I make aren't to gain subscribers or likes. It is just to educate people as much as I can. There are a whole bunch of different things I want to do in terms of videos, and a couple of what I was thinking is like in-depth analysis on games that aren't really as well known but are still extremely fun, like Ark, and why they're not as known, and a whole bunch of different things like that. So I'd love to hear your feedback on that part, and I just hope that you enjoyed. Please share this with everyone you know if you did enjoy, because not only would it help, but it is really good to know that multiple people are learning something new because of me and my stupid research. Of course, you can always subscribe and like if you want, but that is not my main goal, obviously. Alright, I'll see you later. Bye, y'all.